Hey everybody, it's Norm from Tested here. And at Tested, we've used and tested like dozens of printers over the years. 3D printers, even old school paper printers. But one type of printer we've never used before until now is a fabric printer. This is an apparel printer made by xTool. If the company sounds familiar, you might recognize them from their diode laser cutters that they sell. And in fact, they have a bunch of different products and a bunch of different divisions working on experiments in all sorts of product categories. Last year, they put out a silk screening kit also to be used with their laser cutter. And right now, they have a Kickstarter campaign going on for this. This is a prototype of their apparel printer. So when they reached out and asked if we'd be interested in trying it, it was actually perfectly aligned with something we've been thinking about at Tested for a while now, is what it'd be like to manufacture and make some of our own merchandise. This t-shirt that I'm wearing actually was made using this printer. So today I want to kind of give you an introduction, walk you through what this machine is, what these two machines are actually, what the process is like to get a print from this machine onto a piece of fabric or garment, and then take a look at some of the many prints that we've tested over this past month of using the apparel printer and all the things that we've learned from using it. We know there's a whole community out there of people using different types of printers to make applications for fabrics, for garments, for shirts that they're selling in their own stores or on Etsy, and there's a lot of interest in a DTF printer. That's technically what this is called, a direct-to-film printer. Yes, the printer is DTF. Let's get started. So let's start by talking about what these machines are, because there are actually multiple machines going on. It's actually much bigger than we thought this was going to be, although in comparison to industrial grade direct-to-film printers, this might be on the smaller side. There's a printer itself, which is this unit. It lives on top. It's like a large, if you've used maybe a big photo printer, it's bigger than that, definitely bigger than your bread box, but it's connected to and bolted onto this bottom unit, which is called the shaker oven. And it has a very specific purpose that's essential to the film printing process. There's also a separate unit in the back, which is a standard air purifier that xTool makes. It's a filtration system that they also sell with their laser cutters. And it feels like they're moving into the space because they have all the engineering and expertise for these kind of CNC type systems. This one being really one axis going left and right, two axes, I guess, as it's feeding the film through. A direct-to-film printer prints on film. So, while people who sometimes make their own shirts can maybe die cutting or some vinyl or laser cutting a screen print and then screen printing on, here it's printing on basically a film that acts as a transfer, a heat press transfer. I'm going to show that process. But to print on the film, well, first of all, there's a roll of film in the back, and it's like a film like this. You can actually look online and find direct-to-film film that you can buy in rolls, although xTool's version has these notches on the side that then let it carry through the entire system. This feels like the only piece that you really need to buy, the only consumable you have to buy from xTool, which is a neat thing. There's also, of course, the ink. So while they sell ink and they're very proud of their quality of ink, it is blue, red, yellow, black, and white. It is ink that isn't coated in any way. So you can buy your own printer ink that works with direct-to-film transfers and literally just pour it into the reservoirs in here. Very simple, right there. So unlike 3D printing with filaments and maybe chipped printer ink for paper printing, here you can really buy ink from anywhere. There's also moisturizing liquid. So as we understand it, these type of printers are really made to be operating continuously. They're best when they operate in a certain temperature range, certain humidity range, and also when the print heads here, and they're using specifically Epson print heads, are continuously operating. If you let it sit for a week, those print heads could get clogged. And so this machine actually is also made to be kind of on the whole time. When you plug in the Mac, there's actually no power switch. There's only one button here that activates it, but the whole printer is meant to be continuously, over time, if it's not in use, cleaning itself. And it does so with a reservoir full of their moisturizing liquid. They told me that this can also be replaced with just purified water, so you don't have to buy this from them as well, but make sure it is purified water that lives there, and then it goes through that cleaning process. We've tried using this intermittently, and the first time you kind of power it back on or reactivate it, after a while, you go through a full cleaning cycle. Let's take a look at the guts of this. Of course, there is a belt system that drives it along this x-axis. There's a feeder for the film for the y-axis, but the bulk of the brains and the expensive part of this machine are the print heads that live here. And there are actually two print heads, one for the color, as you can see the tubes of ink being fed in, and the second one is all for white. And that's one of the key differentiating factors when you start looking at different types of print processes for clothing. Screen printing works great, but screen printing is typically a single color process. You have to create a different mask, a different screen for each color that then gets perfectly aligned and overlaid. There's sublimation printing, which works great on things like light-colored polyester, light-colored materials. There's direct-to-garment printing, which also works, but doesn't work on polyester, best on cotton. And then direct-to-film printing, which can get heat-pressed on a variety of these soft materials, from cotton to tri-blends to leather and the like. But when you print, for example, on a dark surface, like a dark shirt, and you're printing a full color image, it actually needs a backing layer. You're not just printing the outline of a single color, you need it to be backed with white. The ink itself has a translucency to it. And so that's why there's a whole second print head here dedicated just to that white color. So the film goes in, you're sending an image, and it might be a vector, it might be just like a PNG with a alpha channel, so you get a clear background, so you don't need to print a photo, or you can print a photo, a graphic, anything you download. You load it up into their Creative Space tool, and then you set the scaling, you set how many passes you want, how dense the colors are gonna be. It takes just a minute or two to print through, and then the film with that wet ink gets carried on through those notches into the shaker oven. And this really feels like, even though not technically an essential part of the direct-to-film printing process, what we found is this is really an essential part. xTool is offering the Apparel Printer without the shaker oven, but what comes out of this printer isn't usable. You have to apply a powder, an adhesive to it. That's how this process works. And so again, you can find direct-to-film adhesive online. xTool will sell their own. It's a Apparel Printer powder. And in a manual process, you would then sprinkle in the powder on top of the printed wet ink sheet. The powder is a fine, 100 micron diameter powder that's an adhesive. It sticks just to the ink. And then once you have that powder just on the parts of your print, you then put that through an incremental stage heated process up to, I believe, 110 degrees Celsius. So that goes into your baking process. It cures adhesive, dries the ink, and then your film is ready to be heat pressed onto the garment. That manual process is labor intensive, it requires a little bit of precision, and that's what this oven shaker automates. So the print film goes out of the printer into this area, and you can see there's actually a repository, a deposit of this powder right here. And a conveyor belt will shift and move along and kind of recycle the powder and then it sprinkles it, actually like drops it almost like raindrops onto the film as it goes through. And then there's a baffle here that moves up and it'll actually shake the powder off, that excess powder off. So the powder only theoretically stays on your printed part. Then down this conveyor system is 2 heaters, and the film goes through the heaters, and in about 5 to 10 minutes, depending on how big your print is, it'll come out the bottom and you'll have your usable film. This whole thing feels like an operation where you can be continuously sending these prints and getting a new usable print out in about 10, 12 minutes or so. And the dimensions are pretty nice. So this is about 15 inches and there's a 14 inches of width of usable space. So, larger than what you need for most t-shirts. You can get it printed up to 18 inches tall. So what I thought I'd love to do is walk you through one print, walk you through what it takes to clean and calibrate the printer as our first step to make sure the print head is all clear, and then send something and press a design. Shall we do it? Yeah? Shake that camera up and down, Josh. Shall we do it? Let's do it. All right, so here goes our test image after our deep clean. And you can see there's 2 passes, one with the black and color, one with the white, and we can see if there's any misalignment. And most importantly, we're looking for empty spaces. Like if some of these lines were completely blank, that would mean there would be some clogs and we need to run the deep clean again. As I'm looking at this, there's only a few spots there, which is even consistent. So this is good enough, I think, for an actual operation. As I've been using this printer, one thing I've noticed is if you let it sit, you'll need to run more cleaning passes. Occasionally, after 1 week of travel, came back and started the printer up, and the white wasn't even printing. So it took a handful of cleaning passes to get the white to start going again, and even then, didn't see the full lines. And so we want to really get it to a point where it looks like this before we start using it. Otherwise, you will be missing the one entire color or the white layer. So I've loaded up a graphic. This was made by a tested viewer, Bannister, who's made t-shirt designs for us before. And I loaded up into xTool's Creative Space software suite. It's pretty easy to use. You can just drag and drop, again, your vector files, your SVGs, or your bitmaps, or here is a PNG with an alpha layer, so it doesn't print into a full rectangle. And the most important thing I'm going to select here is my white ink fill. Like I said earlier, there's a big difference between printing on white fabric, in which you don't need the white backing, or dark fabric, in which you do need the white backing. And the white object fill, you can have it fill just the mass, the shape of the area. You can have it fill the full image, like the whole rectangle, or have no fill if you know you're going to be printing on like white canvas or a white t-shirt, for example. You can also adjust how much that white fill is in the back. So I've noticed is in some prints, I've noticed a little bit of white bleed around the edge. And so you can kind of shrink that white fill area to maybe 1 millimeter receded in, and so the bleed won't be as noticeable. We're going to do 100% here, full white in the back, and get this set up to do a 2-minute long print. Here we go. So it's printing our image, and kind of like when I do laser cutting, I really want to maximize the use of the film because it's always going to have a little bit of the header and the footer just to get it through the oven shaker. So every piece of film is usable, printable space. And so negative space here, you might want to just fill in with some graphics. As it's going through, it's getting the first color pass done, and now it's finally hitting the white part of the printer. And so what it should look like to you when it's printed is solid white silhouette, because you have to think of this as being inverted. This is the part of the image that's going to be touching the fabric, and so it needs to be the full white backing with the adhesive powder. And when we flip this film upside down, it'll look correct with the full color on the other side. So far looking pretty good. We can take off this cover to look at the next phase, which is the application of the powder shaking. You can see here that conveyor belt is cycling powder that's fallen through back up and keeping this deposit full. So when the film, as I see it finally coming into the shaker oven, it will start sprinkling it all over the image. All right, so here is our printed and cured film. You can see how wide of an image you get, and you're gonna get some negative space on the top because it needs that to feed into the oven, but this is 14 inches, and one of the things that I've learned as I've been printing is that the size of the image, it's so hard to connect how big an image is on my computer monitor or laptop monitor compared to how big it'll actually be on a t-shirt. Even seeing some type of overlay or representation, you really have to prototype and experiment with size because it might look small on the computer screen when you print it out. It's like, wow, that's actually pretty big. And you can get even bigger. I want to show some other examples of these test prints that we've done and some of the quirks and artifacts we've noticed, as this is still early hardware and not finalized software. For example, one thing that I've noticed is that as it sprinkles the adhesive powder on here, there is extra powder residue that gets left on and cured as part of the process. I think in the shaking, the baffle that shakes the excess powder off, it doesn't do a thorough enough job necessarily of getting all the powder off, and so you do see almost like a light sprinkling there that might show up on a dark garment as you're putting this on, and so you can trim around it, but xTool's told me it's a thing they're aware of and that they can fix in firmware updates later on as they finalize it. Some other test prints I've done, so for example, if the oven is not properly run and it's not heated enough and adhesive doesn't fully set, it'll end up looking like this, where it's not tacky, but you can tell that the ink is still being revealed and that powder has not fully cured yet. So something to be mindful of, it needs to almost have this pebbled texture once the adhesive is fully set rather than this kind of grainy look. The grainy look is not good. Also, in some cases, if you don't have the white ink and the white print head completely clean, you might get print artifacts like banding. So here's an example where the white wasn't fully unclogged, and while the white did still print, and this will work technically on a dark background, you're going to see some stripes in here, which isn't what you necessarily want. I had cases where none of the white, for some reason, actually printed, whether through software error or the nozzle not being clean. And so while I intended to print a solid white back, like this is a success, what came out of the printer was this. Again, something to make sure cleaning is so important to these print heads. And I wouldn't consider this a waste, because without the white backing, this will still work on a white t-shirt or a white canvas apron or something. That will still work. And then finally, I wanted to show what happens if you use the software to reduce the size of your white layer, just so you're not going to get any of that spill. The only setting right now is by millimeters. You can reduce by 1 millimeter. This is the smallest amount of reduction. And what I found is with that small amount of reduction, if you turn them back, you can see, yes, it doesn't fully cover, but also leaves a pretty significant outline of that extra color to a point where you're missing essential parts of the white in some parts of the print. So hopefully in the future, xTool can let the software let me shrink the white down in sub-millimeter increments, not just 1 millimeter at a time. But let's get to an actual application of this. So we're going to take this print and cut it out. And we'll do this one here. There's always this test pattern on the side of the print. And I have, in my use of this, accidentally included that test pattern in the press. So make sure you remove this piece as well. This is great. And to press it onto a t-shirt or garment, you would normally use something like this. This is a heat press. You can find a bunch online. I don't think xTool makes or sells one. You can also do this manually, so you can apply its pressure and heat. So if you have an iron and an ironing board, and I would recommend using parchment paper on top, you can set your iron to cotton or polyester, so it's like 300 degrees or so, and you want to apply pressure for about 50 seconds or so. Pretty significant pressure throughout to make sure it's fully bonded. That's a really laborious manual process, kind of like the reason they made that oven shaker is they want to automate as much of this as possible. So I would highly recommend having a heat press that not only applies heat and time that you can control, but pressure as well. This one will actually put up to 170 pounds of pressure, which is great for pressing on this shirt. I've preheated this test shirt, so it's flat, and we're just gonna put this on. So again, adhesive and white goes on the shirt. We'll put this Teflon sheet on top to protect it. Slide this in here. There's going to be different settings for different types of fabrics. So whether it's 100% cotton, tri-blend, polyester, nylon, which I've tested, all is going to require some trial and error. xTool has their recommendations for amount of heat and amount of time based on their formulation of that adhesive powder. But for me, I found that really trial and error is going to be your best bet to get the perfect amount. So I have this to 310 degrees, and I'll do this for 60 seconds. All right, let's take a look. You know how satisfying it is to get a new piece of electronics and peel off the protective film covering? You get to do this every time. Here we go. Nice. And here's a piece of shirt printed and ready to wear. Let's take a look at some of the test prints I've done around the office and take a look at some results. So after spending a few weeks with this, we've learned a lot about printing on fabrics. The quality of this is super nice. Usually when I think of the screen print, you can do like a full color screen print, like a CMYK overlay, but it doesn't look as crisp. Here, the image looks really nice. It pops. I've printed photos of my children on shirts, and it looks really great. It's also not too heavy as well. It moves with the fabric, so it's stretchy, but it doesn't feel too rigid or stiff. I've had shirts with big images printed on them where it feels like you can feel the weight of the paint or the ink on it. This feels pretty nice. I've also put these shirts through the wash, durability. Now this is short-term durability testing so far because we've only had this for a couple of weeks, but through about 3 to 4 wash cycles, and I've tried cold water and warm water, obviously when I invert your shirts, they've lasted pretty well. Like this shirt has gone through a couple of times, and even the thin type on the shirt here, which reads really well, has held up. Nothing's peeling off. And I think it all goes to your process of how your post-process of how much heat and pressure and time you're putting on. And I've been able to make some fun shirts based on designs I found on the internet. Big Screen's CEO sent me their design, and I got able to put this on a shirt. Again, really fun. But I think also interesting is talking about maybe some of the hiccups and failures and the lessons along the way. Printing really thin line objects works. Like this is an old tested graphic design, but there's slight misalignment, I think, between the white and the color, where I'm not sure if shrinking the white is going to make it work. So if you have a really thin design, you have to make sure that the printer is really calibrated well so that the white doesn't pop out too much from under your thin colorful lines. Also, if you're not applying the film under the post-processing as thoroughly or reliably, you can get artifacts. And so this was an early shirt I did where peeling it too quickly, I would tear some of the letters away. Maybe fine for me to wear, but not fine if someone was making this to sell on their own store. So you got to figure that out. Same thing here, where I found the white color bleed around these pixel characters is something I wish I could remove in a more granular way in the software. We've tried cotton shirts. We've tried, mixture polyester, tri-blend shirts. Canvas works well. I love the look of this logo on these canvas bags. Requires a different temperature setting and a different duration because you can get errors like this. This was the wrong setting and it just started peeling off, and it just needed a different two passes through the heater with time in between for it to cool for this to work out. And then I printed large things as well. I mean, the limiting factor was not even the size of the material or the size of the film. 14 inches across by 18 inches tall is going to be great for even these large canvas bags. Ended up being the heater here, 15 by 15. That was the limiting factor, but I made this nice fun tote bag based on one of these graphics I really love. And then finally sharing this design with Adam. He's really excited about this. He immediately sent me some swatches of his spacesuit material, the things that he uses to mimic beta cloth on spacesuits. And I was able to get his Savage Meatball logo working really well on his fake beta cloth, things that he can sew. So we've already started talking about different ways that we can print on fabrics to add little annotations or something that looks hand-drawn onto things that he's in a pattern, and so using this process. And at the beginning, I talked about, why would someone want this kind of expensive apparel printer, and also something that takes up a fair amount of space. You want to operate this in your garage. And I know there's a lot of people out there who want to make stuff to sell. For us, we might do some small batch manufacturing. So stay tuned for updates in our community post section for tested members. I do want to give some of these extra test prints away because I printed now dozens of these various prints that we might not put on shirts. So I want to make sure some of you get these out there. But we also want to use this as a real prototyping experimentation device. And right now our process involves sending to our printer designs and telling them, the colors, the sizing, and it takes a while to get a sample in. And with this, we can iterate much quicker. Really thinking about this in the same way that I think about a 3D printer and that prototyping process. What is that iteration process? Can I make stuff for manufacturing? And based on our experience with this, with hopefully some software updates, I really believe so. It's not the type of machine that's going to sit here and not be used. So stay tuned for more of our use and testing with the xTool Apparel Printer, and as Adam gets involved with his projects. If you have questions about how it works, please post them in the comment below. If you run a shirt shop and you're curious in this direct-to-film process, or you have experience with it, let us know also in the comments below. I've been having so much fun using this. It's been a long time since I've tried a whole new printing process and felt like it's doing something that I didn't previously have any access to. And so this is really, really cool. So you'll be seeing these shirts on me and on the tested team in the future. Thanks again for watching. I'm Norm. I'll see you next time.
Thank you guys so much for watching that video. I would be remiss if I didn't tell you we have some excellent merch. We have a 5-pack of demerit badges for sale right now at tested/store.com. We've got the I hung it off of level demerit badge, the I built the chair backwards demerit badge, the I hit my thumb with a hammer demerit badge. We've got the stapler in my finger demerit badge, and my favorite, I stuck the duct tape to itself demerit badge. Get yours now, tested/store.store. Tested-store. Tested. It's right here. There. Just click there.